summation n is equal to 1 to infinity 4 into minus 1 power n by n square into cos n x. So we have to nx, then here find the pi squared by 3 plus summation n is equal to 1 to infinity 4 into minus 1 power n divided by n square into cos n pi. So let x equal to pi. So when we apply the f of pi is equal to pi square by 3 plus, see, first one we have to apply the value of n is equal to 1. So when we apply the n is equal to 1, 4 into minus 1 divided by n square is n square, that 1 square into cos n pi. So cos pi. So that we apply the value of cos pi. First of all, we have to find that 1, n is equal to 1, then cos pi, then plus 4 into minus 1 power 2 divided by 2 square into cos 2 pi plus and so on. Then f of x equal to x square, then f of pi is equal to pi square. Then see, pi square is equal to pi square divided by 3 plus 4 into minus 1 cos pi is minus 1 divided by 1 square plus minus 1 square is 1. So 4 by 2 square into cos 2 pi, it is 1. So plus and so on. So here that pi square minus pi square by 3 plus is equal to 4 by 1 square plus 4 by 2 square plus 4 by 3 square plus and so on. So let me take 3 pi square minus pi square, 2 pi square divided by 3, and we'll take the 4 common, then 1 by 1 square plus 1 by 2 square plus and so on, then 1 by 1 square plus 1 by 2 square plus and so on is equal to 2 pi square divided by 4 into 3. So then this pi square divided by 2 3s are 6. So first one is we have to prove that pi square by 6. So that is the first one proof, 1 by 1 square plus 1 by 2 square plus pi square by 6. That is the first proof. So next we will apply the put second one, put x equal to 0. Then it's very easiest value. See, 1 by f of x equal to pi square by 3 plus summation n is equal to 1 to infinity, then 4 into minus 1 power n divided by n square into cos, put x equal to 0, cos 0. What is the cos 0 value? 1. So that is 1. That's all. So then we have to apply the value of 0. Then 0 is equal to pi square by 3 plus 6, 4 into minus 1. Then let me apply the value of 1 divided by 1 square. So plus 4 by 2 square into minus 1 power 2 plus and so on. Then we'll take the minus pi square by 3 is equal to minus 4 by 1 square plus 4 by 2 square minus 4 by 3 square plus and so on. Then we take the minus 4 outside, then take the minus 4 outside, 1 by 1 square minus 1 by 2 square plus and so on is equal to minus pi square by 3. Then we take the 1 by 1 square minus 1 by 2 square plus and so on is equal to pi square divided by 4 3s are 12. So that is the second proof of this one. And the final one is very easiest, because we have to take that this one is 1 and this one is 2. So add the equation of 1 and 2. So add the equation of 1 and 2. Then finally we get the value of C 1 by 1 square. Here also 1 by 1 square. Here also 1 by 1 square. Then 2 by 1 square. 2 by 1 square. Then minus 1 by 2 square plus 1 by 2 square will be cancelled. So plus 2 by 3 square plus also 1 is equal to, we have to add that pi square by 6 plus pi square divided by 12. So 2 will take common, so 1 by 1 square plus 1 by 3 square plus also 1 is equal to 2 pi square plus pi square, 3 pi square divided by 12. 3 pi square divided by 12. Then 1 by 1 square plus 1 by 3 square plus also 1 is equal to pi square by 4 into 2. So that is pi square. So this is the final proof of this one. So 1 by 1 square minus 1 by 2 square plus also 1 pi square by 8. That is the final.